So check whether following list of numbers forms an AP or not, and if they form AP, find the common difference D and write three more terms. So I'll pause the video, you check the answers and match with my answers. Okay, so if we see A1 is root 3, A2 is root 6, which can be rewritten as 6 as can be written as 3 into 2. So if you separate out the 3 and 2, it will become root 3 into root 2. Same way A3 will be root 9, I can write it as root 3 into root 3. A4 as 3 into 4, I can write it as root 3 into root 4. So now if I take the difference between A2 minus A1, I'll get root 3 into root 2 minus root 3. So if I take root 3 as common, I'll get root 2 minus 1 in the bracket. So the difference between A2 minus A1 is will be root 3 in the bracket root 2 minus 1. Similarly, A3 minus A2, if I take root 3 into root 3 minus root 3 into root 2, I get, if I take root 3 as the common, then I get root 3 minus root 2 in the bracket, and since root 3 times of root 3 minus root 2 is not equal to root 3 times of root 2 minus 1, hence it is not an AP. So we don't need to find further the difference between A4 minus A3, since A2 minus A1 is not equal to A3 minus A2. So whenever the numbers are in roots, so we just cannot say just because 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, so hence it is an AP. It cannot be like that because they are numbers in roots. So we need to simplify them and check whether they actually are part of the AP or not. So be very careful whenever you're solving the numbers which are in related, which have roots also. Okay. Okay, next question is 1 square, 3 square, 5 square, 7 square, whether it is an AP or not. Check the answers, pause the video and check whether your answer matches with my answer. Okay, so simplifying this, A1 will be 1 square is 1, A2 that is 3 square will be 9, A3 is 5 square that is 5 into 5 is 25, A4 will be 7 into 7, 49. So if we find the difference, A2 minus A1 will be 9 minus 1, 8. And same way, A3 minus A2 will be 25 minus 9 will be 16. So since A2 minus A1 8 is not equal to A3 minus A2 which is 16, so hence it is not an AP. So whenever you have squares and like this, we should not just say okay 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, so hence it's an AP, because everywhere is 2, 2, 2, 2. So not like this. So you need to simplify the numbers, write the numbers without the square, and then see what are the actual numbers, then find the common difference, whether they are part of the same, they form part of the AP or not. Okay. Okay, given the list of numbers 1 square, 5 square, 7 square, 73 and so on, we need to check whether they form the part of AP or not. So, and also find the common difference D if they are part of AP, and three more terms. So pause the video and check your answers, they match with the answers I am going to solve. Okay, so squaring the numbers, 1 square is 1, 5 square is 25, 7 square is 49. So A1 is 1, A2 is 25, A3 is 49, A4 is 73. So if you find the difference between the two consecutive terms, A2 minus A1 will be 25 minus 1 is 24. Similarly, A3 minus A2 is 49 minus 25 is 24, and A4 minus A3 is 73 minus 49 is equal to 24. Since we see that the difference between two consecutive terms is always 24 for the given list of numbers, so hence it is an AP. So the common difference is, that is D is equal to 24. Since it is an AP, now we can find out three more terms using the generic nth term formula, which is A n is equal to A1 plus n minus 1D, where A1 is the first term and D is the common difference and n is the nth term. So since we are given four terms, we need to find out fifth, sixth, and seventh. So fifth term will be, using this formula, it will become A1 plus 4D, and A6 will be A1 plus 5D. Seventh term will be A1 plus 6D. So replacing the values A1, D, we get A5 is equal to 97, A6 is equal to 121, A7 is equal to 145. So hence the next three terms will be 97, 121, and 145. Okay.